Ever wondered how to find the area under a curve for something like this? Today, we're diving into the powerful world of integration to solve this exact problem. Our goal is to find the integral of the function 4x squared minus 6x plus 3. The first step is to break down this complex expression into its simpler individual parts. Think of it like disassembling a complex machine into its individual gears. Now, for each part, we use the fundamental rule of integration, the power rule. It's like a universal key that unlocks the integration of any power of x. Let's tackle the first term, 4x squared. Applying the power rule, we increase the exponent by 1, making it x cubed, and divide by the new exponent, 3. Don't forget to multiply by the original coefficient, 4. Next, we move to minus 6x. Again, the exponent is 1. We add 1 to make it x squared and divide by 2. Multiply by the coefficient, minus 6, and we get minus 3x squared. Finally, the constant term, 3. Here, the exponent is 0. We add 1 to make it x to the power of 1 and divide by 1. Multiply by 3, and we simply get 3x. Now we bring all these integrated parts back together. We combine our results, 4/3 x cubed minus 3x squared plus 3x. But there's one crucial piece missing. When we integrate, we're finding a family of functions, each differing by a constant. That's why we always add the constant of integration, c. And there you have it. The integral of 4x squared minus 6x plus 3 is 4/3 x cubed minus 3x squared plus 3x plus c. This means we've found the general form of the function, whose derivative is our original expression.